Okay, so this is section 6 for solutions to linear systems using matrices. Then there's a little extra note that we'll discuss at the end. So I'm going to skip over the size of the matrix and just look at what are called augmented matrices. And these are the ones that we're going to use to solve the equations. So a matrix is an arrangement of numbers, and usually they can be meaningful or maybe not so meaningful. For us, we're going to use these matrices. Augmented means that it has this bar here, and to the left it represents one thing, and to the right it represents another. So we have a system of equations, 3x plus 5y equals 6, and negative x plus 2y equals 0. And we can put it into an augmented matrix, but notice we only put the coefficients. So the 3, the positive 5, and then the equal sign is the bar, and then the 6 on the right hand side. And then the other one is a negative 1, that's a coefficient, a positive 2, and a 0. Okay, so that's an augmented matrix, and we use it to solve systems, to represent first systems of equations, and then to solve them. Okay, so let's first learn to kind of represent or put the system into an augmented matrix. So let's look at this one, x minus y plus z equals negative 2. So the coefficients are 1, negative 1, 1. There's 1, negative 1, 1. The equal sign, and then the 2 on the other side. Negative 2, I'm sorry. The next equation, 1, negative 2, 1. 1, negative 2, 1. And then the 0 equals 0. And then there's no x, so x is 0. That means there's 0x, 1y minus 1z equals 1. Okay? So we're able to write a system into an augmented matrix. Okay, now there's some very special augmented matrix. So one of them is called a row echelon form of the augmented matrix. And the row echelon form is identified by the zeros here. Okay? At this corner, right? What this the way you look at it is, this is called the main diagonal, starting from the top left and going diagonally down. Okay, that's called the main diagonal, and below the main diagonal, it's all zeros. Okay, so let's look at an augmented matrix that's representing a system of equations, and it's in row echelon form, right? So you have the main diagonal, and below it, you have the zeros. Okay. Well, it turns out that we can kind of go in reverse, right? If we look at, let's go back to this one, and if we look at this bottom line, that's 0x plus 1y minus 1z equals 1, and we can just write that equation. Yeah, and it's the same thing here. We can take the very last line, and this very last line says 0x plus 0y plus 5z, which means just 5z equals 10. And notice if we have it in row echelon form, that this very last line allows us to solve for z, right? We divide by 5 and we get z equals 2. What does that do for us, right? Because we just have one variable. Well, we go up a step. Yeah, we go up a step and look at here. This says 0x plus 2y plus 3z equals negative 4. So that's just 2y plus 3z equals negative 4. Except we have a value for z, and we can plug it in there. Okay? Let's pause there and just look at this next thing that says backward substitution. And this says the bottom row tells us z equals 2. That's referring to this system right here that we're looking at. Now substitute in the second line, that's the one we just wrote, and solve for y. Then substitute your values for y and c and solve into the first equation to solve for x. This is called backward substitution. So once we have the matrix in row echelon form, then we can just solve backwards, right? Just work backwards to solve for all of them. And so let's do that here. So I'm going to write that here. So we have 5z equals 10, which gave us c equals 2. Then we have 2y plus 3z equals negative 4, and we can replace the z. So this is going to be 2y plus 3 times z, which is 2, equals negative 4. This is 2y plus 6 equals negative 4. I subtract 6 and I get 2y equals negative 10. And then divide by 2 and I get y equals negative 5. Sorry, I wasn't showing you what I was doing. There you go. So now I have y and I have z. So I go back up to the first line. This line says 3x minus y plus 0z equals 6. That's 3x minus y equals 6. I'm going to write that down here. 3x minus y equals 6. Okay? And that equation, because I have some numbers already, I have the value of y. So I have 3x minus, and y is negative 5 equals 6. 3x minus y equals 6. So this is 3x plus 5 equals 6. We subtract 5, we get 3x equals 1. And divide by 3, so we get x equals 1/3. Okay? Now, how do we write this answer? Sorry, I'm covering up again. How do we write this answer? Well, x is 1/3, comma, y is negative 5, comma, z is 2. That order triple is my solution. And I can check my solution by plugging it into my system, right? And I know what the system is. It's 5z equals 10, 2y plus 3z equals negative 4, and 3x minus y equals 6. Okay, and just plug it into each place, and it should give me a true statement, assuming it's the right answer. All right, so now, the only problem is that we usually don't get systems that are in row echelon form. So we give some rules that allow us to fix that. Okay, so here's the rules. So any two rows can be switched. We can multiply a row by a non-zero constant. That's because it's an equation, right? So we can multiply by any number. And we can add two rows and replace a row with the result. And so let's see how that works. Let's try number 1 together. So first I'm going to write this in an augmented matrix. This is going to be, and I choose the order in which I enter my equations, okay? I'm just going to keep them in the same order. So this is 1x plus 1y minus 2z equals 3. The next one is negative 1x minus 1y plus 3z equals negative 1. And then 1x plus 2y plus 1z equals 12. Okay, and so here's my thinking process. That I can, if I add, notice we can add we can add two rows and replace a row with the result. So if I add row 1 and row 2, this will be a 0. Remember row echelon, I wanted zeros down here at the corner, right? If I add row 1 plus row 2, this will be a 0. Okay, so I'm going to do that first. Okay, so and I documented, by the way. This is the way you document things. So you say, you decide where you're going to put the result. And I always think of, I'm going to add row 1 into row 2 and leave the answer in row 2. So my documentation goes in row 2. That'll be right there, row 2. And I'm going to write row 1 plus row 2. Row 1 plus row 2 in row 2. Okay? And then I'm going to take the negative of row 1 plus row 3. Notice if I take the negative of that plus that, that'll give me a 0. And notice I'm concentrating on this column right here, these two zeros. Okay? I said the negative of row 1 plus row 3, and I'll put that result in row 3. What am I going to do with row 1? I'm just going to keep it. 1, 1, negative 2, 3. When I add row 1 plus row 2, make sure you just be very careful. Do it term by term. So 1 plus negative 1 is 0. Notice you're looking for that. 1 plus negative 1 is 0. Negative 2 plus 3 is 1. 3 plus negative 1 is 2. All right. Now, negative row 1 plus row 3. So negative of that is negative 1 plus that is 0. Negative of that is negative 1 plus that is 1. Negative of that is 2 plus that is 3. And negative of that is negative 3 plus 12 is 9. Okay, so I'm good so far. And here's the deal. Notice if I just had these two rows switched, that I would have the 0 there and the 2 zeros down here, and that corner would be all zeros. And I can do that. I can just switch row 2 and row 3, and I'm going to do that on the next step. How do I indicate that I'm switching row 2 and row 3? Let's write row 1 first. Notice row 1 never changed, right? It kind of did temporarily when I said negative row 1 plus row 3. So I'm going to switch row 2 and row 3, and I'm going to just write that. You can either write it in row 2 or row 3, and the way you write it is row 2, the arrows to both sides, row 3. Okay? I'm switching row 2 and row 3. So row 3 is going to go here, and row 2 is going to go here. Okay? All right, so let's finish this off. I think we can finish it. This is z equals 2. This, I'm going to move it up here, and this is y plus 3z equals 9, but z is 2. So that's y plus 6 equals 9. Subtract 6, we get y equals 3. Okay, now let's see if I can finish this in this video. I'm going to take now the first line, and I can get it from anywhere, from here, from here, or from here. I'll take it from here, it's the same line. This is x plus y minus 2z equals 3. I have a number for y though, and for z. Okay, so this is x plus 3 minus 4 equals 3. That's x minus 1 equals 3. And so x equals 4. Okay, so how do I write that? I write 4, 3, comma 2. All right, and I can check my answer by just substituting each of those into each equation and just making sure that that's a true statement. All right, I'm going to stop there for this part, and then we'll continue. We'll do number 2 next on the next video.